So now in principle, we have two different shapes or types of surface gravity waves. The one is called the plane surface gravity waves, and the other one is called the circular gravity wave. The circular wave is just the wave crests are all connected through circles, and you get something like this by throwing a rock into the water. These circular waves. Tsunami waves are also often look like this because you have a local singular center, the epicenter of your submarine earthquake, and creates a circular wavelet. Okay? Plane waves are more on a situation where the wave crests are oriented parallel. Okay, so that's good to know. All right, but there's a type of waves which are called shallow water waves, and these type of waves are the waves that we can actually simulate with a single layer model, a model that only has one layer of fluid. So how do these waves look like? And these waves look like they have a wavelength which exceeds the water depth by more than 20 times. This is shown here above my head. This is how the structure looks like. Okay, so the wavelength exceeds the water depth 20 times or more, and tides are features like that. And something that we call swell in the ocean is also something like that. These are wind waves that are modified as the waves move through the oceans. And these waves approach shallower water, they turn into long waves. Shallow water waves are long. Anyway, so how the water movement looks like, and this is shown here on the top right. And essentially, a water parcel moves back and forth, up and down, sort of an elliptical path. So there is no net movement to zero order approximation. Okay, so there is no movement, just upward, back and forth a little bit. If you go to the seafloor, it's just a pure forward and backward movement, okay, oscillating movement. So now if you look at these waves, you study these waves, what you learn is actually that the speed of these waves is exactly square root v times h, and h is the total water. So the phase speed of these waves exclusively depends on the water depth. And if you use that additional relationship that the phase speed is given by wavelength over the wave period, you can work out that here on the right-hand side that the wavelength is given by the wave period times square root g times. Okay, and this is just something that if you develop a computer-based model, this is something that you have for comparison. You can test your phase speed, and you can test this relationship between wavelength and wave period. By the way, it's called the dispersion rate. Okay,